Two application domains associated with this are on this slide that shows you some concept of, for example, doing self-driving in the cloud. So you may be aware that a lot of self-driving companies are stopping their work on self-driving because of accidents. And one reason why accident happens is because the autonomous machine learning is not good enough to deal with the overall big picture of driving. So whereas cloud can maintain lots of information and can do closed loop things as long as we can keep the latency down to 5-10 millisecond range. So that's an example of a high bandwidth application with a mix of sensing and low latency. There are, of course, many other applications. Previous speakers today spoke about augmented reality and virtual reality and industrial control. So in thinking about all this, we spent some time to try and come up with some functional requirements for next generation networks, whether it is called the next generation mobile core or next generation internet. We feel that the really important functions can be clustered into several groups. One is, of course, the basic function of supporting mobility, which is not a trivial thing. There are a lot of such functions in the 3GPP spec, but when we evolve towards these new applications, we are talking about a connectionless environment with seamless mobility, and that might involve computing as well. So when you have edge computing with a mobile user, that involves migration of both the connection endpoints as well as the compute endpoints. The second area is that because we are talking more about wireless technology, multiple interface-related functions become really useful and important, such as multi-homing and multi-path, for example. Another important topic that some speakers today touched on is that of context and content support. So we'd like to see systems in which the routing can be context-aware, where you can find out what kind of quality of service the application needs and then respond to that inside the network. So I'm not going to go through all these. Just to finally, I should mention that in-network processing, which has been a major topic in today's discussion, is a very important part of the future network. Due to the bad name of active networks, not sure why it got a bad name, the research was quite good. There was a 20-year pause in thinking about these issues, how to introduce computing into the network. And I think what we have seen is that computing has already been introduced into control plane via SDN technology, and it happened quite quickly. I think the next step with P4 and other such technologies is that we're going to see mainstream acceptance of in-network processing, and sometimes it's very important to have it in the network because of the speed we talked about. So we can't always maintain low latency if we go up and down the protocol stack. So how to do things like media transcoding or cloud service integration or data aggregation from massive IoT, all these kind of applications will be very interesting to see how we can support them efficiently. So this is just my brief introduction.
Thanks. Okay, so I'm shocked to realize that I'm that old that I already experienced the first wave of future internet research in the NSF and EU research, and now I'll take some time. And actually even the wave before. So initially people thought IPv6 would be, the future internet, and lots of hopes have been made, and in the end, the result was really disappointing, because just the fact of having a new packet format and supporting more addresses doesn't really enable, say, new ways of networking or new applications. The other wave I mentioned was the NSF and EU Future Internet Research almost like 10 years ago. And so thinking back, so one of the lessons that we learned is that design by committee for the grand vision of future internet never really works. So it's a recipe for failure. And so lots of taxpayers' money had been invested in those efforts at the time. And I think there are two noteworthy things that actually prevailed from all that work. And so number one is the concept of programmability, so like OpenFlow, P4, data plane programmability, these kind of things. And the other is basically moving away from pipes and supporting this notion of multi-access, multi-homeness better through a perhaps data-oriented approach. So mobility first, ICN, NDN, these kind of projects. So having said that, so I'm a bit skeptical that it's really possible to predict the future internet in 10 years. But what we can do is maybe learn from those lessons and try to identify at least pillars that help us to evolve networking in a way that we can perhaps support more interesting types of application in the future. And so one approach in that context that was already also mentioned is how can we actually really put more functionality into the network. And so Nakao-san this morning in his keynote had some super cool examples how this could look like, with the flying camera system that was doing deep learning and analyzing features and so on, collaborating with other parts of the network. And so looking at these kind of trends, so we have lots of technology for supporting computation quite well in networks. So starting from virtualization, telco virtualization, NFV. We even have NPUs, so AI on mobile devices these days. And we can use that for building new things, so like connecting technology to the real physical environment, for example. That's super interesting. But all the things, all these kind of examples, solutions that we are seeing today are only point solutions for a particular use case. They are all in their own silos, essentially. So we are kind of lacking a, say, good general abstraction how to build these things in the future. So how we can, nowadays we can instantiate compute functions on the order of milliseconds. But we have networking technology that requires us to do a DNS lookup, get redirected to an edge compute function here and there, terminate TLS, HTTP, and so on. So there's a certain gap. And so this is illustrated by different examples. So here I picked one example from the IETF service chaining work, whereas the assumption was if I'm able, to control the way that the packets flow in the network, I can magically intercept application layer flows and do something on them. That's, of course, only workable in a very well-controlled telco environment. It's not usable in a general case where you have security, privacy requirements, transparency requirements, and so on. What you also briefly discussed this morning was that there are these different types of, say, in-network applications or functionality that you could talk about. So doing things like analytics, as Nakao-san also discussed, that doesn't require you any changes. That doesn't require any changes in the protocols. Also, if you want to program the network, where we have technology, as we have just seen in previous talks. But if you want to start distributing application functionality, so like machine learning, like AR support, for example, then you really have to think about a, say, holistic vision about, conceiving a framework that supports computation without giving up important properties that are expected from a network. And I mean, like something like failure safety, good performance, ability to leverage multiple paths in the network, and so on. So I'm currently working on an approach where we try to leverage say, modern technology instead of just keep using technologies that we are used from CDN or say legacy edge computing systems. So we have powerful compute technology, we have trusted execution environment, we have new networking abstractions, so like ICN or named function networking, new programming models like reactive programming, and we have new ways to decentralize trust and security in general. So can we use that for building networks where computation is not just added as an afterthought, but really a first-order service or principle? We no longer basically run VMs and use our legacy protocols to connect them. And so that approach is called compute-first networking, and so we are trying to really make it easier and more reliable to use computation in different places in the network. And so we believe that this gives you the ability to design applications that are no longer dependent on centralized cloud, for example, where I can outsource computation to my local network environment. I can trust the computation. The, say, compute node can also trust me to some extent, and I don't need to go through Google or PKI to make this happen. So this is kind of my, say, intuition or my proposal, what could be interesting to support new applications in the future.
Okay, good afternoon, everybody. So I'm Abhimanyu Gosain from Northeastern University. The hat I'm wearing here today is Technical Program Director for this new initiative funded by the National Science Foundation in the US called Platforms for Advanced Wireless Research. The goal here is essentially to develop infrastructure at large enough scales pretty much at city scales across the US to essentially enable future networking, future comms, future sensing, and future applications. So just to, since this is new for the US side of things, I always have this slide. In Europe, public-private partnerships are the norm, but essentially it's been set up as a PPP with funding from the NSF as well as an industry consortium, which sort of came together, pitched in about $100 million that have been split 4 ways. We have 2 platforms, actually. Professor Ray Chaudhary is a PI of one of the first platforms that's going to be deployed in New York City, and one is being funded in Salt Lake City in Utah. And for more details, please visit the website. I'll publish the slides, etc. So to switch gears as to what we want to do here on the discussions around the panel and what we've heard so far today, I want to wear the outsider's hat on the panel here, being a wireless guy as well as an applications guy. So pretty much tethering both ends at the last mile wireless comm service as well as at a higher layer on the stack in the application side. I tried to put together some of the sort of key metrics for your question, and I took it quite literally to mean how is the internet ready, and if it is, or if it is not, what are the kind of key features or key principles that might be needed to support future applications in the current and in the upcoming internet. I think the first word's openness. I think all of us here imbibe that. And again, open community, open interfaces, open APIs. So everything we've heard, at least from the first 2 panelists, that talks about in-network processing or the ability for the network to be smart enough, some of that capability needs to be exposed up to the application developers, whoever they might be, or to the comms people who are your last mile providers outside the edges of the network where you live. And the biggest thing is, I think you touched on it towards your last point about the operators essentially controlling everything in their own siloed environment and in the networks that they own top to bottom or are fully vertically integrated. With 5G, with network slicing, the ability to have multi-tenancy, to have multi-operator federation, to have microservices, to have customer touch points in your network is extremely scary. And at a policy level, it's, we don't want to get into that discussion, but that's something that's extremely hard and has not been thought through yet. The customers or the application developers seek and want cloud-native innovation. They continuously want feedback as to what's happening to their applications from the network side, so they can adjust, they can adapt. I think, I forget where I was reading it, but apparently Amazon's updating every 7 seconds based on their feedback that they receive. I think back in the day, Zynga, the Farmville game, was updating 40 minutes. In a span of 3 to 4 years, the number of updates, applications, and services are making has gone down from minutes or 40 times a day to once every 7 seconds to optimize. So the burden that it puts on people who are building networks or network capabilities is extremely immense. So I wanted to put that out there. I think KK made a very interesting point after, I think, the second keynote, which was around the culture, which was the rethinking the application development about should electronic engineers or should robots be doing things in the same control loop they've been doing and expect the network and the providers to essentially satisfy those requirements without having a feedback loop which tells the application developers what's happening in the network. I think some of the techniques, some of this compute-first networking, some of this first-order principle work, I think that's a very interesting idea. But that's something that I think we as a group, as well as the community we cater to at the higher layer should be made aware of. And again, I'm a big believer in openness and APIs and interfaces, so that's something that we should continue to foster. Thank you.
Okay, my name is John Lui, and I'm from the Chinese University of Hong Kong. Talk about whether Richard was asking whether the current internet can support the future applications, and I was thinking that as a researcher, obviously I would say no, right? I mean, especially if you're you're from company or from funding agency, I would definitely say no to you. But anyway, so I mean, I think the first thing I would like to point out actually is. I think today, we talk a lot about technologies. We talk a lot about, how we can do the e-network computing. But there's one thing that I want to emphasize actually is the economics models. And I think it's because of the economics model they're not aligned, that creates a lot of deployment problems, okay? So I'd just like to quote, there's a saying about, by this guy, Oscar Wilde, who's an Irish poet and playwright. He basically said that, when I was young, I thought money was the most important thing. Now that I'm old, I know it is the most important thing. So money actually is extremely powerful, and so is economics. So I think the important thing I want to point out actually is that when we want to think about future network, future applications, we have to think about who are the players, how can they benefit. If they can benefit, I think the whole community can benefit. So if you look at the networking community, we have the equipment providers, we have the content providers, we have the internet service providers like the local ISP, regional ISP, transit ISP. The transit ISP, definitely they're in trouble, okay? And of course, you also have the users. The reasons why I said the ISPs, they're in trouble, actually it's just because of a lot of technologies, what I call disruptive technologies that came along. So for example, when P2P network came along, the transit network is basically saying that, hey, wait a minute, I have to, ship all these packets and I'm not earning a lot of money, okay? And then later on, the cloud providers come along saying that, hey, just connect to me because I have clouds, distributed cloud data centers, around the globe. And you can just replicate data and so on and so forth. So the question is, what type of innovation we need in the network? Okay, so from the cloud providers, they'll be asking, like, how can they do slicing and virtualization with guarantees? We talk a lot about how we can do slicings, how can we do virtualizations. But when we talk about large-scale deployment, distributed deployment actually is not an easy task. How can we provide all these with guarantees? Okay, from the content providers, we can differentiate between small content providers and large content providers. If I'm a small content provider, let's say a small company, I can just set up a web page on the cloud. I basically want connectivity. I want availability. I want some bandwidth and QoS. But for large, content providers, okay, they will be asking more difficult questions. Like, for example, can they control? Can they add caches? Can they add differentiated service? Different type of new functions into their own virtual network. Okay, assuming that the ISP can provide this type of virtual network to them. Can they provide their own traffic engineering? Carry out their own traffic engineering. Okay, so that they can optimize a set of applications. Can they carry out their own data analytics? I think right now, especially for content providers, they want to carry out their own data analytics. So how can they do it? Where can they add nodes? From the regional, local and regional networks or ISP, they want to ask, can they learn about the applications and the impact on the networks? Can they predict the future? Can they add new functionalities efficiently? Richard a while ago was asking about applications. Okay, I personally believe that if we're going to go for this Internet of Things, okay, there will be huge amount of data. Okay, and not only from the there are many different type of IoT applications, but one thing we should not ignore is a lot of time actually we work at home or we work in the office. So the homes and office, smart home and offices, they will generate a lot of data. Okay, they may be small amount of data, okay, on a per user basis, but they have different type of requirements. Now, how can we take advantage of the edge computing and ship the things through the network and then do the data analytics and so on and so forth? Lastly, oops, I don't. Okay, so I think there's a lot of opportunities for networking research, like for example, e-network and edge machine learning. One thing that I really want to emphasize actually is that when we talk a lot about innovations, for example, we talk about compute first in the network. We have to think about how we can understand this program. Okay, I mean, we have all written program, and we all went through how to debug the program. Now imagine that you put all these compute first service in the network, and somehow it just called dump, and then you just don't know what the heck is going on. Okay, and the worst part is that a few hops down the road, there's some new services because some graduate students want to use deep learning, and then we don't know what the heck is going on about deep learning. I mean, it can be extremely frustrating, okay, for the content providers and so on. So I think we may need to consider about new set of network management tools, new set of network measurement tools. I really like the idea about programmability. Okay, giving more capability to the programmers or application developers. But at the same time, I think we also need to think about security. Okay, I mean, we may not think about hackers, but it's very easy even for legitimate programmers to make mistake, right? I mean, I remember when I was a graduate student, I was running some simulation. I was saying, hey, I don't want to sit in front of a terminal. I just kind of pipe it to a file, okay? And then I run, and then I just went home. And the next day when I came in, I say, oh, the file server is so slow. And I said, oh, who kind of jerk, produced this kind of problem? It turns out it was my program because I keep writing so many data. And then and the operator, I mean, the system administrator didn't set the disk space limit. So what I'm trying to say is, we have to think more about, we think about programmability or compute first. We have to think about security. How can we do isolations? How can we do testing? How can we do debugging, distributed debugging? And there's also in other areas about protocol designs. I think right now with the advancement of machine learning, in particular online learning, okay, how can we adapt? Okay, how can we learn about the parametric values and adapt our protocol? Okay, so I think these are a lot of opportunities for researchers, for graduate students, and yeah.
session. So the questions for the panelists. Actually, for some questions, they have already answered, like Doug honestly answered some of them. So, but anyhow, suppose you have something new you just want to say. So the first question is, what are the most representative applications or use cases in the future? Can our current internet support them? So,
just quickly, I think I mentioned something related to it. If you look at two applications, one of them would be how to connect a client to an edge cloud service. Right now, you'd have to do it through DNS in the internet model. And there are a lot of other limitations. So latency and such things are also, some people have spoken about that. That's one example. If you also want to do something simple in the IoT space where you want to query the cars going on a highway, suppose in New Jersey, we want to query the engine temperature of BMWs in a particular segment of the road, it should be quite easy to do. But today it will generate about 10,000 messages, not including the signaling messages. So because there are 21 signaling messages per IoT message, we may be looking at 200,000 messages just to get a fairly simple thing, which could be done through in-network compute aggregation and multicast. It could be done in a very simple way. So these are examples where IP cannot really meet the requirements. And people don't worry much about it because on top of IP, people have been designing their own stovepipe vertical stacks for each application. And IoT is particularly doing that very quickly. So after that, it will be too late to have a more general solution. So that's one of the challenges.
Yes, you actually don't have to look that far into the future to talk about this question. So if you look at so we are all cutting our cables and moving to internet video consumption, and well, you can really if you talk to people, to companies like the BBC, for example, they can really project the day when they're going to run out of money because they have to pay CDN so much to get their public broadcasting content distributed. And so part of the reason why this is so difficult and expensive today is that we have all these powerful features like EBMS that you also mentioned, so the broadcast extensions to LTE and 5G. But it turns out with the protocols and say the way we consume video today is actually incompatible. So it does not make sense to use a broadcast system with a connection-oriented networking model. And so this is an area where we can already see we have to really evolve our networking tech to enable massively mobile content consumption in the future and also content production, by the way. And so this is, I think, the way that application requirements will go. So you will have, say, mobile user devices that attach to different types of networks that want to use, say, connection-oriented services, at the same time receive broadcast. And these shouldn't be two different worlds. You would like to have one technology that supports both use cases really well.
I might like to go on the other direction. So I think mobility is well understood, connected cars, URLLC, kinds of applications. I think you touched upon broadband. Talking about the 1% that's remaining, so rural, large scale deployment areas and what the use cases for those really, remaining, I guess, 1%, which still equates to about 30 million people at least alone in the US. That is some, again, might not be a very quote-unquote sexy application or use case, but that's something that's lagging really, really far behind as to what, and that's, for that our current system might support them. I think an example that's usually given at least by Henning Schulzeren, who's sort of the CTO at FCC, is the operation of DOCSIS and 2G systems in rural areas in the US, and I don't even think about what's happening in other underdeveloped countries. So a little bit of a positive before we actually go into the other extreme and talk about mobility. I just want to acknowledge that too.
Today is 1%, could be like 10% in the future.
Yeah, so there are economics and politics at play where you have about 95% of the population, at least in the U.S., is going to be living in East Coast, West Coast, and a little sliver in the Midwest, and everything else is not there. So,
you talk about 5G. Okay, as far as I understand, when data move from cellular network to the IP network, there's a lot of conversions. There's a lot of signaling. And I'm not even sure. I mean, for me, I think this is a lot of overheads, okay? And you really need an expert who knows both type of protocols, okay? Because from a traditional app developers, I mean, they just open up a socket, and then they just pump packets, right? But the thing is, they don't realize that there are a lot of signaling overheads, So someone. I'm just thinking that someone may need to look at how we can clean up all this overhead, and at the same time, I believe that edge computing or some form of caching may help, but to what degree I don't know. Okay. Now another thing about programmability, actually, I remember last month I was visiting a university and talking to graduate students. He was saying that he did a trace studies about a parameter server. Okay, because they were designing some type of distributed machine learning architectures. And then they find out that there's a lot of problem. After 3 or 4 months of digging into the data, they find out that actually it's because some of the object that people use, okay, on the TCP stack actually it was poorly designed. And it just occurs to me that maybe that's the curse of object-oriented programming, because right now when we try to compose software, we just try to grab object, and functionally they work. The problem is when you scale things up, you just find out that what the heck, they're so slow, and then the performance is just totally unacceptable. And engineers and graduate students have spent so many hours just to go through all the objects, so I guess what I'm trying to say is software actually is extremely complicated, and when we want to put again compute first in the network, we also have to be aware about these danger. Okay, as well as software management, software testing, yeah.
We have talked about the future application use cases. Right now, let me, if I may ask you, what major challenges to the current internet, right? So in the previous civilization, we talked about latency, jitter, all that comes in compute first, and P for programmability. So in the future, got to be some major challenges. So today, Professor Rahim, give a very interesting keynote. He challenged us with some 5 senses, 3D and dimensional. He also did a test there. He said that the quality is low there, but it works there. But in order to make better, so right now, should we design a new internet, or we just design a new suite of protocols, or just we change it, update it, improve it in the same way as we have done this in the last 45 years? Or is it really right time, good time to start to consider to design a new internet? So what do you think about it? What's your thoughts?
Okay, so I'll come out in favor of designing a new internet, and I think the reason is that if you work in standards committees, you'd see that there's a lot of legacy and a lot of reluctance to change, and some of it is based on existing business interests. Another part is based on the technology becomes very structured and it's very difficult to change it. So I think that what we need to do is take a more pragmatic approach to a new internet design. For example, edge network architecture can be made completely new, but it can you can show how to interface with the wide area IP, and BGP could still be used for interdomain. So I think there are ways to introduce functionality like ICN type functionality can be added at the edge and gradually spread. So I think this is the way change happens in society also, that it usually at the very edge of society, somebody starts to adopt something and then it gradually spreads. So I think for research people, it will be particularly valuable to produce working code as well, which allows people to quickly produce these kind of solutions and test them in the edge network and then migrate it into code.
Okay, so let me try to disagree a little bit. So I don't think it's particularly productive to start a major new internet design effort or something. So the internet, I mean, has been evolving all the time, and so we invented new protocols, new management approaches, and so on. So there's also really lots of experience. So what is doable, and some of the issues also regarding business models. So many of the, say, grand visions of a new internet that had been tried in the past have miserably failed, to be honest. And I think it's more productive, to think about interesting and relevant enough functionality that you can, provide, let people use it, and that may kind of contribute to the evolution of the internet. And by that, I mean good initial deployment strategies, the use of overlays, these kind of things. So even the internet didn't replace the telephone network on a flag day. So it was run as an overlay for a very long time. And so I'm a bit skeptical when people say, let's start a new internet design effort.
Just have so don't want to bore anyone with a history lesson, but essentially if you think back to, it's a complete what it was envisioned to be versus what it has become today. It has sort of morphed itself. And again, there were some key enabling reasons, the most recent being 2007 Steve Jobs and the iPhone. And essentially it's become sort of a very reactive strategy on our part, essentially in the networking community, where essentially you have a killer application or something that causes you to react within the network and create a patchwork of strategies. I think an example, Ray, you also mentioned the stovepipe vertical stack that lives above IP. So it's a radical approach. I think there's definitely a lot of merit. You obviously want to learn from the failed attempts that happened before, but I am a big proponent because I think the recent success, especially in this community around OpenFlow and SDN, actually happened using that same model, which was developed on the fringes, adopted bottom up, and essentially caught the attention of the tier 1, tier 2s, and now obviously it's represented heavily here at premier venues, etc. So I do see, again, I'm conflicted. I do see both approaches. I'm sorry, I'm a boring panelist here.
I actually, it's kind of, I agree that, there was two networks, right? Telephone network and the internet. And I agree that, there was no flag day that, people tear down the telephone network. But I think we can go back to history and think about how the internet took over the world, how they can, just wipe out the telephone network. I think in the beginning, there was this telephone network in terms of connectivity and reachability. It was much better than internet, okay? Internet style to be small, not every household was able to get into the internet. But internet, I think at that time, they have one crucial weapon that telephone network didn't have, and that is, it has this open API, there's this socket, okay? It allows innovations, okay? In the telephone, I mean, the only interface you have is, 0, 1, 2, 3, 4, 5, 6, 9, okay? I mean, you can only dial number, okay? That's the only interface you have. So I think, slowly when the internet grow, people basically can say, hey, I like this network because I can create new services, new applications, and then eventually I think the economics model is basically shift toward the internet. And I think, if you want to have more innovations, we need something like that. We may have to start something small. I don't know whether it's a new network or overlay network, but it has to allow people, all the players, to have the economics incentive to say that, hey, I need to get into this network rather than the old network, because it just provides, better functionalities or better time to deliver for new services or better management. So, I from a practical point of view, I cannot imagine that, we have a flag day that, hey, we have a new internet, okay? Because if you tear down the internet, I think a lot of us will feel very, very painful. Like I go to China, I feel painful. I cannot connect to the internet, so I think it's an evolving process, okay? But we do need to start something new. I don't know whether we need to start at the university level or in the research level or in the home level. We want to build these IoT applications, but and as to whether it's a new network or overlay network, I don't know. Yeah.
I just want to add a comment. So if you look back to 1990, BGP was adopted widely over a period of 3 to 5 years. It's very fast. If you compare with our personal experience, we have to wait a long time before something is adopted. But BGP adoption was very fast. And the reason was, again, that it provided a mechanism that didn't exist. Telephone networks were hierarchically organized, controlled by the government. People wanted a more open and democratic style network, and this is what BGP allows. So it happened quite quickly. So we have to produce something which is equally important, whether it enables democratic edge computing or whether it enables low latency, something new that people want. And then once you have many bottom-up solutions, 1 or 2 of them will be adopted. But of course, most of the research projects will not be adopted, right?
Comments on this?
What would be nice would be to have more, facilities for actual experimentation at larger scale. So that has previously slowed down the development of new ideas.
Actually, that's what Manu spoke about. In the US, at least, there's a belief that large-scale experimentation with realistic environments and real user will help drive these things.
Okay, so right now we have built up small community here. So people come here, fly here just for this. So I will open that later. So my last question for you guys is, what's your best suggestion to this community and to this workshop? So anything, if you have, just talk about it. If not, just pass.
Okay, no, this is a hard question, but I would like to say that you have to believe in innovation in networking. I honestly think that a lot of people gave up thinking that IP pipes are the only thing possible and nothing else should be considered. I think there's a lot of room for innovation, and my suggestion would be don't lose hope about the innovation.
Yeah, my suggestion would be to really do research and innovation a bit more from the application perspective. So really try to think about so what could be cool new applications and how could we support it from a networking side. Don't try to solve, say, all the problems at once. So I agree that business models and so on are important. On the other hand, when the guys in ARPA designed the packet network, they also didn't think about business models, and also Tim Berners-Lee didn't really think so much about business models. And so these things can evolve, and so really try to build something maybe that combines application and networking software development.
I think just look outside your community, look outside your comfort zone. Essentially, I think that's an important thing. It's the best thing if you can optimize your solutions or make things a little bit better, but effectively, if it's of no use to somebody who's at a layer higher than you or a layer lower than you, it's not really going to have a significant impact. I think venues such as this and the broader conferences actually do a good service to the community, allow you to speak to others who are working across different communities, and myself included. I try to attend as many of these conferences across different disciplines to sort of keep abreast of what's actually happening and what might be beneficial. You'd be surprised how many hallway conversations end up with, I have the exact thing you've been looking for. So that's just it.
I try to give a broader answer, okay, because you know, I face a lot of graduate students, and then whenever new graduate students comes in, you know, you ask them what do they want to do. They say, hey, you know, I just want to do deep learning. I mean, I don't know what the heck it is. I just want to do deep learning, okay? And I really worry about that because if so many people, you know, let's say 90% of the graduate students want to do deep learning, by the time they graduate, you know, 5 or 6 years, you know, all the good jobs will be, you know, won't be available, and they'll be in deep trouble, okay, instead of deep learning. So, but if you look at the, you know, networking community, I really think it's a fascinating community because, you know, it is an area that you can really create, okay, and create innovations, you know, both from a software perspective, and at the same time, you can include a lot of algorithmic and in mathematics techniques, you know, like machine learnings and all this, you know, like analyze traffic, you know, how can we do network tomography, okay, how, you know, all these sort of things, and I think, you know, network actually is a really, for me, it's a very interdisciplinary area that you can, you know, pull in different algorithms, mathematics, and experimentations, and it's not experimentations within an office. Okay, you can do large-scale experimentation, you know, around the globe. Okay, so I always think that, you know, I mean, it's really an exciting area, and yeah, so.
All right, thank you, guys. Right now we're open to questions. Okay.
I've been involved with these new internet initiatives for way before probably half of this room was born. Would you put in the new internet that failed information-centric? Because I'm sorry, because for the example that you gave for BBC, I heard at least one startup who started with exactly the same thing, that the BBC will get out of money because they need to distribute content, and their way of solving it is using ICN. Can anybody of you comment on this?
Right. So I wouldn't say that at all that ICN kind of is one of the examples that failed. But what failed was the approach to basically redesign the internet with a specific ICN protocol at a time. So the concepts of accessing named data, securing application data units, leveraging native broadcast capabilities, and so on, I think we see this today, that this gets more relevant and is also used by the startups more. So that's a good example. So you have to understand two things. So one is the technology, and one is the, say, overall approach. And for the overall approach, I think it's always much better to have a, say, modular, say, evolution-oriented approach, where you find a way to introduce your new cool networking concept into the system and make something useful today or at least tomorrow, but not in 20 years or something.
Any other questions?
It's more probably more a comment kind of thing. Probably you can respond. So in the sense that, I mean, because somebody had mentioned about IP and why IP was so successful, because of its simplicity, people could innovate in the upper layers and put it on any kind of layer 2 technologies. And there was this economic model and the whole set of the internet built around it. And mostly, it served most of the application requirements. And then we had the keynote that talked about the URLC kind of applications. and I think Professor Ray brought a good point. And if you really put that kind of application on loaded networks, it's never going to work. It's never going to give that kind of guarantee. And then we had the BPP kind of protocols that can probably carry some of those guarantees into the network. So it seems to be that, I think this was a comment somebody made earlier, that eventually probably it's not one internet. You're going to end up with multiple internets that can, but of course it requires its own economic model, but will give you that kind of guarantees and has its own reasons for existing, right? So I don't know, that seems to be, because at the end of the day, it's both applications, it's both the economics, and the hardest part is the infrastructure that nobody wants to change, right? And the infrastructure requires to be changed only if there's an incentive to do that, and applications have to give you that incentive. I mean, they have to provide the economic value for changing that. So if all this comes together, I think it would be like more parallel internets in the future. So that's a comment. I mean, it's a comment, but I think the panelists can respond to that.
I'm feeling happy to hear all your opinion about year 2030. So I gave a keynote today and talked about we are generating lots of data in the mobile network, and we are the one that use network, and lots of data is a result of that. Our activities are generating lots of data, and we talked about lots of technologies. And we are trying to understand the network which moves bits around. But observing this, lots of data is generated in the network. Isn't it the time when we build the infrastructure that tries to understand us using this data? And can we do this by year 2030? The network that understands our activities predicts what. We are joking around this graduate student who like to do deep learning, but maybe we shouldn't be joking around that. Maybe younger generation are looking into possibilities of doing DNA-based things.
So what's the best answer to your question? According to you, you are keynote speaker. You must have something in your mind.
Yeah, so actually I wanted to respond to that earlier this morning already. So I'm not sure it's really desirable to have the network understand all my activities at all times. So in fact, many people are trying to avoid that, right? So we are starting to use DNS encryption these days and so on. So I think we have to be a little bit careful. I can understand that there is also some good utility in a sense if the network can support applications well, of course that's good. But if the network needs to know the nature of my communication and maybe who I talk to and so on in order to do that, that may be not so good. So I think you want to have a good balance between those. And so what we are trying to develop in this compute first networking idea is a system that tells the network say things about the nature of a distributed applications. So, but not in an application-specific way, but more in general. So this needs a certain co-location of components. It has certain communication requirements. These kind of things. So, in the keynote this morning, I didn't quite understand why the network needs to know whether a user is using Chrome versus Firefox. I really don't want the network to know.
It's I guess a double-edged sword, at least in my mind. There's a technical and an ethical aspect. On the technical side, obviously, you want a zero-touch orchestration, self-healing, self-organizing networks. You want to give as much capability in the network as you want. in addition to the data question that you posed, metadata-driven, catalog-based, again, how much of that data can be leveraged, used to optimize what the network's doing. That I still think, at least I don't have a good understanding. I'm sure there might be other experts in the room of what that data, how that's being used, how that's being cataloged, what that metadata is being used for, how that's actually, how's the loop being closed effectively. And then obviously, again, don't want to waste time with the ethical, moral, big government, et cetera, implications of that and why, you know, I mean, yeah, if family members or friends who are not technical get spooked when you visit a website and the crawler basically suggests that you should be buying this product. I mean, that is freaking people out. So I can't even imagine if networks start, you know, playing mind tricks with folks, like what the implications might be.
I guess what you meant is not the network understand what I am doing, but you know, whether the network can understand. I mean, the network actually, there's a lot of data. Whether the network can help, let's say, content providers to do better traffic engineering, to answer the question like, where should I play the service? Because imagine, actually, one time I was talking to a senior level person in the WhatsApp, and you know, he asked me, say, oh, right now I try to have this video call, and you know, most of the time it's okay. Suddenly, it's not okay, and I want to find out what happened, which link dropped the packet, or what happened. I mean, even answering this question actually is extremely difficult, right? Because the WhatsApp, actually, they have their overlay network, and it goes to many different, I mean, so if you, that's why a while ago I talked about, you know, we need to rethink about network measurement and management, because honestly, we can't even answer that questions. Okay, if you go back to the telephone network, actually, I think telephone network put in a lot of effort into signaling to understand what's going on. So again, and I guess what you meant is, you know, with all this data, can we, if we're going to build a network, you know, can we have some type of design goal in mind saying that, you know, can the network inform us so that we can do better traffic engineering? And I think it's an important question, okay, because if I'm a large-scale content providers, you know, I create my overlay network, I talk to different cloud providers, I do caching. I want to find out in my network what happened, right? You know, I want to find out and aggregate user behavior, okay, or aggregate traffic behavior, right? Yeah.
So maybe just quickly, that's actually a good point. So maybe coming back to the question of a future network. So this has been something that has been really hard in IP in the past, to have applications express their requirements, say, in terms of load or, you know, congestion contribution and so on to the network. And that could have been actually one of the reasons why people invested so much in DPI to actually figure out more what's going on. So that could be one idea for a future network, that we, you know, provide better mechanisms for applications to, say, express preferences, you know, help the network but in a explicit way. So not requiring the operator to, you know, sniff on your packets, but you know, just enabling a better cooperation between applications and networks.
So we will accept last one question, short, make it short.
So I have one question regarding the business models that were mentioned, and also there were certain talks and so forth earlier that talked about the compute theme to put to basically enable people to put compute in the network and so forth. So with regards to that, where do you see basically future network and the accounting schemes and so forth? Is that so sufficient, or what are the possibilities there? Can you perhaps comment on this one briefly?
I mean, I think economics, I mean, helping, you know, for example, from the equipment provider's perspective, okay, you want to sell a lot of equipment, you know, routers and switches, you know, to your clients. You have to know what your client wants, right? I mean, and I think there are many different types of clients. You know, you can have your ISP, cloud providers, users. Maybe those are the things that can help you to decide some of the important features, okay? Because, or can you just aggregate into some common features, okay? Common functionalities that you can provide different type of features. So understanding the requirement, what your client wants, I think is important, and whether the current network can provide this type of service. If they can't, how can deploy it in a scalable manner? If they cannot, what additional functions we have to put into the protocol, into the network stacks? Yeah, I mean, these are challenging questions.
I know we're towards the end of the panel, so I hate to disagree or have a counterpoint, but if you flip the script and you look at the content providers or the ISPs, the last thing I want is proprietary equipment. I mean, the whole push towards SDN, openness is pretty much to lower the leverage of what equipment providers have been able to do. So openness has become the norm. Effectively on data center networking, that's sort of been the business model. So everything's GPP, and essentially OTT players then take and customize and tweak, effectively, killing the margins, I guess, for proprietary solutions, which doesn't mean that that proprietary optimizations don't really exist. They do, and a lot of vendors do take an open blueprint and essentially customize it. But the thing is, it's a trade-off and a constant friction between the upstream. Yeah, it's a tussle. So, but again, I don't think we directly address that. I don't know if others.
Yeah, so I earlier pushed back a little bit on the business model discussion, but on the other hand, you are of course right. So there are some interesting, say, implications. So assuming you buy into the idea of adding more compute functionality into the network, and then so we think you would not do this for necessarily saving money or making the network more efficient, but rather to enable growth, right? To enable new crazy